Hello student, now we have discussed here LRC circuit with DC source. So in this scenario we have to find current in this circuit at time t. So we can write here the potential difference across the resistor, that is VR, and potential difference across the inductor, this is VL, and potential difference across the capacitor, this is VC. So VR plus VL plus VC is equal to V. So right here the potential difference across the resistor, that would be IR, this would be L di by dt, this would be QIC. Here the capacitance is C and charge is Q. So differentiate this term with respect to time, di by dt R L d2I by dt square plus dqic, this becomes 0. So rearrange these terms, t2I by dt square R by L di by dt and 1 by LC, this becomes dqi dt. This becomes dqi dt current, dqi dt becomes current. So we put here I is equal to e raised to power mt and differentiate this term di by dt, this becomes m e raised to power mt and d2I by dt square, this becomes m square e raised to power mt. So put this value here, e raised to power mt term would be cancel out and the quadratic becomes r by L m plus 1 by LC. This becomes, this is the second order differential equation and this is a quadratic equation. As we know, the quadratic equation is ax square plus bx plus c is equal to 0, then its roots will be minus b plus minus under root b square minus 4ac upon 2a and discriminant will be b square minus 4ac is less than or equal to 0. These are the conditions for the root. If this discriminant is greater than or equal to 0, then the roots will be real and distinct, unequal, and if b square minus 4ac is equal to 0, then roots will be equal. Then when b square minus 4ac is less than 0, then the roots would be imaginary. So applied here, so we can see here, if r by 2l whole square minus 1 by LC, this becomes greater than or equal to 0, then the roots will be real. The situation is this, for this particular situation the roots are real and distinct and unequal. So the solution for this second order quadratic equation, second order differential equation would be I at time t, current at time t, that would be C1 e raised to power m1t plus C2 e raised to power m2t. M1 and here m1 and m2 are roots for this quadratic equation. This is the quadratic equation. Oh, this is the second order differential equation and current for time t if roots are real and unequal. So this is the condition of overdamping. This is the condition of overdamping. If roots are real and equal, roots are equal, then the current would be C1 e raised to power mt plus t C2 e raised to power mt. Roots are equal. So this is the condition of critical damping. Critical damping. So the value of m would be minus r by 2l. Third condition is roots are imaginary. So current would be in this circuit at time t, that is expressed as e raised to power alpha t C1 cos beta t plus C2 sin beta t. So alpha and beta are roots here. So alpha plus minus iota beta, this is the roots. So alpha plus iota beta, alpha would be minus r by 2l and beta would be under root 1 by LC minus r by 2l whole square. This is the alpha, this is beta, this is the condition of under damping. So here we show these conditions. This is the current at time t, this is current at time t, this is the over damping, the process is slow, this is under damping, this is over damping, this is critical damping. So in this situation, over damping, the system get equilibrium position at very slowly. In this position, the system get equilibrium position very fast at once, and this is the situation of under damping. This is situation of over damping, this is critical damping, or this is the situation of under damping. Here the current versus time graph, and in this situation the current, the amplitude of this circuit is exponential decreases. Here the oscillation is placed in this situation, this is under damping, and this in the both scenario the oscillation is not placed. So we can define here the damping ratio. This is damping ratio. This will be alpha upon omega naught. So alpha is r by 2l. This is damping factor. This is damping ratio. So r by 2l into 1 root l by LC. So this becomes r by 2 under root c by l. This term is damping ratio. For this condition, damping ratio is greater than 1, and this condition damping ratio is 1, and this condition and damping ratio is less than 1. This is the LRC circuit with DC source. So we take some example. We take an example to understand this topic. So here we take some values to find the current at time t. So suppose the resistance is 100 ohm, inductance is 2.5 Henry, and capacitance is 1 millifarad, and voltage is 25 volt. We have to find here the time at t is equal to 0, the current in this circuit is 0, charge is also 0, current is 0, charge is 0, and we have to find the current at time t. So we find the situation here. The circuit is in what mode, either it is under damping or over damping or critical damping. So we find the discriminant here. So R by 2L whole square 1 by LC. So put the value here. Resistance is 100, 2 into 2.5, this becomes 5, and this becomes 400, and 1 by LC, this is 2.5, so 1 micro minus 3, this becomes also 400. So values 1 by R by 2L whole square minus LC, both values are equal, so this system is under critically damping condition. So we can write the current equation here for critical damping. So this would be current at time t, C1 e raised to power mt plus C2 into t e raised to power mt. So m is minus R by 2L, the value becomes into 5, this becomes minus 20. So in this equation, at time t is equal to 0, the current is 0, so this terms become 0, so this terms 0, C1 plus 0, so C1 becomes 0. Put the value in equation 1, so I current at time t would be C t e raised to power mt. Differentiate this term. So di by dt, current at time t, di by dt, C2, first function m e raised to power mt plus e raised to power mt, differentiation of t is 1. So we can write potential across resistor inductor, that would be L di by dt. L di by dt. So this is 25, inductance is 2.5, and this term is di by dt. So C2 mt e raised to power mt plus e raised to power mt. So here we put the values of at time t is equal to 0, current is 0, so putting the value of t is 0, so this term becomes 0 and only this terms. So e raised to power 0, 1, so C2 becomes 10. So putting the value here, so current at time t would be, this term is 0, so C2 is 10 t e raised to power minus 20 t. The value of E is minus 20. So this is the current at time t. So this is RLC circuit with DC source. I hope you better understand this scenario. So thanks for watching this video. Thank you.